We've been continuing on talking about how trig functions are related into the unit circle. I went over the basics of what a unit circle is and the angles that are created from that. We have radians and degrees and how to convert back and forth. We talked about coterminal angles, which are multiple names for the same angle. And now we're talking about common trig values. So as we go around the unit circle at different angle values, what are some of the sine, cosine, and tangent values that are there? All right, let's look at one type of right triangle that comes. Now in this unit circle, as we go around to the 360 degrees that are possible, let's look at some key angles here that have some common patterns. I'm looking at the radians that have a denominator of 4. In this case, it's 1/4 of a radian, or pi over 4. It's a 45-degree angle. Now, if we look at that 45-degree angle, and we notice how on the point of the circle here, these are the xy values, or the cosine sine values. But as always, we can always make a right triangle and look at it as if it's sort of a geometric problem. This will give us our radical 2 values, as you can see here. So this is a 45, 45, 90 triangle. Now let's look at the properties of such a triangle like that. So in that kind of angle, we have a 45, 45, 90 triangle. Now this is a special triangle because it's not only a right triangle, but it's an isosceles right triangle, which means that each of these vertical and horizontal legs here are congruent to each other. Now we know that in a unit circle the hypotenuse is 1 unit long. That's that longest side right there. So being that these are 45-degree angles and that these are congruent, when we plug it in, or at least look at it and analyze it with the Pythagorean theorem and what we know about right triangles, the legs both have to be radical 2 over 2. That's just mathematically how it turns out. So whenever we have a 45-degree angle, it means that this other angle is 45. We have a 45, 45, 90-degree angle. We know the hypotenuse is 1 and the legs have to be radical 2 over 2. Both of them are the same. So what does that mean in the unit circle? That means that this leg is radical 2 over 2 long, and this leg is radical 2 over 2 long. And that's consistent throughout whenever you have a 45, 45, 90 triangle. Remember also that in this unit circle, the x values, that's the right or the left horizontal component, is always the cosine value. All right? So cosine is the first number in the ordered pair. That means that the vertical component here is the sine value. All right? So couple of things you're going to have to memorize or remember: that these ordered pairs of the points on the unit circle is the cosine value followed by the sine value. Now that's the x or horizontal amount after first, and then the sine or the up and down vertical amount. So that's where we came up with radical 2 over 2 and radical 2 over 2. They are both positive. So if we look at a similar situation, let's go ahead and open up this angle to 135, which is 3 pi over 4, 3/4 of a radian. Okay, let's go ahead and look at this hypotenuse here. That's 1 unit, we know. And if we make a right triangle, it does happen to be a 45, 45, 90 triangle, just like on the other side. Now, of course, what that means is this is 45 degrees, that's 45 degrees, and our sine and cosine units are the same. This vertical piece here is radical 2 over 2, and that's where that comes from. And the horizontal piece, which is the cosine value, we're going to go backwards now, radical 2 over 2. So that's why it's negative radical 2 over 2, positive radical 2 over 2. So knowing that it's a 135-degree angle, or a 3 pi over 4 angle, it results in a 45, 45, 90 triangle, and then you can remember that these are these radical 2 over 2 amounts. So you just have to recognize what kind of triangle is formed. Let's look at one more example just to make sure that you understand. Let's go ahead and open up this angle all the way around, almost a full rotation, to 315 degrees. Now that's 7 pi over 4. Notice the 4 denominator, that's your clue. that it must be some kind of a 45, 45, 90 triangle. Now if I draw this hypotenuse out here, notice again we can make a right triangle from that to determine our cosine and our sine values, and there it is. There is my 45, 45, 90 triangle because that's 45 degrees right there. That must be 45. That's of course 90 the way I drew it. And we have this vertical piece here, which is the sine value, right? And that's got to be radical 2 over 2, but notice it's negative. That's why we have that there in the second part of the coordinate. Now this piece here going from the origin straight out, again that's the leg of a 45, 45, 90 triangle, and that is radical 2 over 2. It is going out in a positive direction, and there we go. Positive radical 2 over 2. Keep this straight. This x value is the cosine, and that would be this right here, positive radical 2 over 2. And this vertical piece going down is the sine value. Alright? And that happens to be negative radical 2 over 2. Alright, thanks for watching this video, and we're trying to keep track of what kinds of these right triangles are formed. And the previous video is all about thirds and sixths. And here it's about fourths because it's a 45, 45, 90 triangle. Look forward to the next video, which will have a problem set, and we try to keep all these things straight. So thanks for watching.